Hey there! Welcome to the CS Flatmates, where computer science meets fun. If you've ever felt like OS concepts are harder to crack than a coding interview, don't worry. I've got you covered. Today, we are diving into what is process scheduling. And trust me, by the end of this video, you'll get it without pulling an all-nighter. So let's jump right in. First, what is process scheduling? Imagine you are at a doctor's clinic. Many patients are waiting. Only one doctor is available. The doctor can't treat all patients at once, so there must be a proper way or a system to decide who gets treated first. Similarly, in a computer system, many processes want to use the CPU, but a CPU can handle only one process at a time in a single core CPU. Hence, process scheduling is the method used by the OS to decide which process gets the CPU next, how long it stays there, who waits. Definition. Process scheduling is the activity of the operating system that manages the execution of processes by deciding the order and allocating CPU time. Why is it important? To maximize CPU utilization, to reduce waiting time, to improve response time for users, to make the system fair for all processes. Without scheduling, some processes might starve, never get a chance, while others hog the CPU forever. Before moving to scheduling categories, let's learn what is preemptive and non-preemptive scheduling. Preemptive scheduling. In preemptive scheduling, the operating system can forcibly remove a running process from the CPU even before it finishes, to give another process a chance. Interrupt and replace if needed. A real-life example: a doctor urgently leaves the current patient to treat a serious emergency case, where it is useful when we need quick response times and real-time and interactive systems. Non-preemptive scheduling. In non-preemptive scheduling, once a process gets the CPU, it keeps it until it finishes or voluntarily leaves, like waiting for I/O. No one interrupts? Let the process finish. Real-life example: a teacher finishes helping one student completely before moving to another, no matter who asks urgently. Where it's useful, simple systems where switching processes frequently is expensive. Different types of scheduling algorithms. Let's think of scheduling as different rules at a doctor's clinic for calling patients. Each algorithm is a different rule. First one, first come first serve, FCFS. How it works: the process that arrives first gets the CPU first. Real life example: standing in a bank queue. Whoever comes first is served first. Pros: very simple and easy to understand and implement. Cons: convoy effect. Smaller ones have to wait too long if a big process comes first. Poor average waiting time. Second one, shortest job first or shortest job next. How it works: pick the process with the smallest burst time or shortest work first. Real life example: at a hospital emergency room, small injury patients are treated faster. Major surgery patients wait longer. Pros: minimizes average waiting time. Cons: hard to predict the exact process length beforehand. Starvation: longer jobs might never get a chance. Third one, priority scheduling. How it works: each process is assigned a priority number. Higher priority processes run first. Real life example: VIP patients in a hospital are treated first, regardless of arrival time. Pros: important processes are handled first. Cons: starvation of lower priority processes if high priority processes keep arriving. Solution for starvation: aging. Gradually increase the priority of waiting processes. Fourth one, round robin RR. How it works: each process gets a fixed time slice or quantum. If a process doesn't finish in time, it returns to the queue. Real life example: playing video games with friends, everyone gets a 5-minute turn, then the next player. Pros: all processes get equal CPU time. Good for time sharing systems. Cons: if the time quantum is too small, too many context switches or overhead. If the time quantum is too large, behaves like FCFS. Choosing the right time quantum is critical. Fifth one, multi-level queue scheduling. How it works: divide processes into different groups or queues based on type. Example system processes, interactive processes, batch jobs. Each queue has its own scheduling algorithm. Queues have priorities. Real life example. In an airport, there are different lines for economy, business, VIP travelers. VIP is served first. Pros: organized management of different types of processes, suitable for complex systems. Cons: rigid. A process cannot change queues easily. Difficult to balance. Some Q&A. Which scheduling method is best for real-time systems? Priority scheduling, because urgent processes like real-time alarms must be handled immediately. How can starvation happen in scheduling? In priority scheduling and SJF, longer or lower priority processes keep waiting forever if new shorter or higher priority processes keep coming. How can starvation be solved? By using aging, increasing the priority of a waiting process over time. Final note: each scheduling method fits different kinds of systems. Real-time, priority scheduling; interactive systems, round-robin; batch processing, FCFS or SJF. Here's the table for your reference, where each scheduling is mentioned with its pros, cons, and real-life examples. That's a wrap. If this video helped you, make sure to hit like. It really helps. And if you think your friends could use a little OS wisdom, go ahead and share it with them. And of course, don't forget to subscribe and hit the bell icon so you don't miss out on future videos. See you in the next one. Until then, happy learning.